Hi guys, today we are going to work on graphing, and so we're just going to talk about kind of the basics of a generic graph. And so we're going to be plotting data and working on putting titles in our graphs and working on our scales. So as we go through the notes, make sure that you are filling in your notes packet as you're watching this video. Don't just watch it, actually fill in the notes. You're still responsible for them. So for starters, we're going to look at the basic parts of a graph. Okay, so make sure that you are on this page, and we've got a whole bunch of different things, so I'll just kind of take a swing around here. So we've got our dependent variable, and generally the dependent variable is going to be your y variable, or what we'll put in the y position. So we'll plot that dependent variable along that vertical axis. And that's the value that gets calculated depending on whatever the independent variable is. So that's why we call it the dependent variable. That goes along the vertical. Okay, now speaking of independent versus dependent, we've also got an independent variable. Now the independent variable, sometimes we'll use a variable x, a lot of times time will go over here, and so the independent variable does not depend on the other. And so that will go along our horizontal axis. And on both of these, always include your units. So in this example, we've got the number of tests that I need to grade, and the more tests that I grade, the more cookies I eat. Okay? It's a fact of life. It gets me through. And so as the number of tests increase, the number of cookies I eat increases as well. So the number of cookies that I eat depends on how many tests that I have to grade. So then some other things that we'll need to include in our graphs are titles. Okay, so if you're graphing real life data like tests and cookies, it's a true story, I ate a lot of cookies, then we'll need to include a title. So in this one, you could call this Tests and Cookies. Okay, and the title will give the viewer, whoever's looking at your graph, a quick snapshot of what the graph is about. Okay. And then the last thing we need to discuss are scales. And so the scales are the numbers that you're marking along the sides. And we need to be really careful with our scales because the scales really determine what's happening here. And so in this one, I end up grading quite a few tests. So if in one class I grade 100 tests, I'm eating, it looks like 9 cookies. That's actually not so bad. 100 tests is a lot. And so we'll need to include those numbers. You wouldn't be able to tell about the number of cookies or tests if we didn't have these numbers on here. Okay, so you can see those. And what's really important with the scales, it says down here, consistency matters. That just means you can't go from 0 to 1 and then for the same distance, like 1 square, we can't jump and make that 5 and then the next time make it 2 and then the next time make it 20. We need to be consistent. So each time you'll notice each of my squares going upward is 1. So you can count and just go in order 1, 2, 3, 4, 5. Well, across the bottom, I needed to show more. I needed to go up to over 100, or at least to 100, so I couldn't count by 1, so this time I did by tens, 10, 20, 30, 40, 50, and so on. Okay, so then you'll get into some actual examples. So we're going to look at practice number 1. And for starters, I keep meaning to correct this. I apologize. There's an extra row in here, so you'll see a duplicate. 10, 45, 40, 10, 45, 40. We only need one of those, so just cross one of them out. And so this says we need to plot our data on the grid provided, and it doesn't really give us anything for scale yet. And so the rules are we need to fill our grid as much as possible and label our scales. All right. So, and we'll need a title, we'll need to figure out what's independent, what's dependent. So let's take a look at what you're graphing here. We've got depth in meters, and then we have 2 different plants that bubble. So we have the number of bubbles per minute for plant A, the number of bubbles per minute for plant B. So what's happening is we actually have 2 sets of data that are our dependent variables. And so to figure out which one is which, you can say the sentence. The number of bubbles from a plant depends on its depth in the water. You wouldn't say the depth in the water depends on the number of bubbles on the plant. So these bubbles, this is what we're going to put on our vertical axis. Okay, where the depth in meters, so that's already giving us our title for our axes, that is going to go along the horizontal. That's our independent variable. Okay, so we can think of a name. We're looking for bubbles on plants, depending on depth. Could be some variety, so I just put plant bubbles by depth. Okay, so then we need to figure out how to set up these axes. Like I said, we're going to put depth across the bottom. We're going to put number of bubbles along the side. And so what we need to think about are, well, what's the biggest number we have in here for depth? We're going from 2, and then the biggest number I see is 30. So I've counted these for you. There are 30 squares across. So if we need to go up to 30, we can count by ones across the bottom. Okay. And we'll call this depth in meters. And our other axis, and I'll swing this around, is going to be number of bubbles. Okay. Now for our number of bubbles that we have along the side here, let's take a look. Now we're looking at both lists. And if you look, the smallest number I see over here is 10. Looking for smallest and largest. And then I see a 50 here. Let's see if there is anything bigger than 50. I don't see anything bigger than 50. So we need to go anywhere between 10 and 50. There are 25 squares, so why don't we make each square 2? Right? If there are 25, then we'll go all the way up to 50 here, and we'll be able to include everything. So you're looking for, in each one, your smallest value and your largest, and you're going to use those to set up your scales. Okay, so let's go ahead and mark these off. All right, you can see that I've labeled depth in meters, and I'm not labeling every single one because that takes a ton of time, and then you won't really be able to see much. So I just marked off and counted every 5. So then I counted by 5s, 5, 10, 15, 20, 25, 30. And then in this direction, I counted by 5s, but each 5 is now 10, because remember there are 25 squares, and we need to go up to 50. Okay, so pause the video if you need, so that you can label your 2 axes with their names and scales. Don't forget to title your graph. All right. Welcome back after you've paused. So now we need to answer a couple of questions. We kind of glazed over what some of these were, right? We talked about independent versus dependent variables, and we said that the number of bubbles depends on the depth. So the depth is going to be your independent variable. And so it's independent because the depth doesn't depend on how many bubbles a plant is going to give off. It's the other way around. The plant gives off the bubbles the further down in the water it goes. Kind of a funny example. Okay, so the dependent variable is just what we just said, the number of bubbles. And this is for each minute. And so think for a second why this is the dependent variable. So something along the lines of the deeper you go, the more bubbles there are, it changes based on the depth, etc. All right, so now you're going to want to have 2 different colors, otherwise it gets really confusing. So we're plotting both of these sets of data on the same grid. Okay, so I'm going to plot my plant A in blue because I outlined it in blue, and my plant B in red. So I'm going to get my blue pen ready. Let's see if this is too big. A little bit. It's not so bad. You'll be able to see it. So I'm going to plant 2 meters, 29 bubbles per minute. So I'm going over here, 2 meters, and then, well, we've got 30 here. Remember, we counted by 2, so this is 38. So we're going to write in between for 39. Okay, I'm sorry, 29. And then 5 and 36, I'm going over 5. And I'm going to keep with my line. I'm going up, here's 30, 32, 34, here's 36 right there. And so then go ahead and continue plotting these, working your way through both sets of data. Pause the video if you need. If it's hard to tell where you are on the graph, you can always use a straight edge to kind of mark off how far out you're going, so that way you don't get mixed up by all the different lines. Okay, so again, pause the video if you need a little bit more time plotting. And notice I've color-coded these. Okay, that's key. So then we're going to answer these questions, saying what can you conclude? It should be about plant A and plant B based on this data. Okay, so plant A, if we look at this, that's the blue one. If it helps, go ahead and connect the dots. You won't really be able to connect absolutely everything, but let's see, we can do this. It's approximate, but there we go. So then it gives you an idea, especially if you used the same color. That's going to really help you distinguish and differentiate between the two. And I'll connect the others. And wherever it looks approximately linear, I'm going to shortcut. Okay, so now we can really clearly see kind of the top value for both of these. So let's use our graph to interpret, sort of like what we did with our distance time graphs. So this says, what can you conclude about plant A and plant B based on the data? So plant A is going to have more bubbles per minute than plant B when? So here we've got more bubbles for plant A than plant B. So up until 10 meters, looks like, plant A has more bubbles. After that, plant A starts to drop off. Plant B is still increasing in bubbles up until, looks like, what is that, 16 meters? Okay, so that's something we can say. So at smaller depths, plant B has more bubbles per minute. At larger, deeper depths, plant B has more bubbles. So we've got that. And then plant A and B will have about the same number of bubbles per minute, somewhere in here, right? And that is, well, close to about 11 meters. Okay, so somewhere between 10 and 15. This is all approximate because we just plotted a couple of data points. Okay, so then you are in charge, of reading through the next example. Use the first one to help you out, but you're practicing. You can work together, and you're setting up your scales. You're deciding on a title. You're going to label your axes. This is very, very similar to the last problem. Okay, so pause the video again if you need, and work together to graph practice number 2. Okay, hopefully you've paused it and you're now just checking. So a title that could work is glucose levels over time. We're looking at time after eating and glucose levels in the blood. And looking at the data, the values over here, if we're looking for the glucose levels, I'm looking for the biggest number and the smallest number over here. So the smallest number I see, somewhere in the 100s, not in this list. It looks like maybe 130. Okay, where the largest number, I see 245, 230, 235. I don't see any 200s over here, so it looks like 245 is our winner. That's our biggest value. So when we're setting up these axes, that's why I went all the way up to 250, so that I can include that 245. Now, on the other axis, that's where I'm putting time. I'm going all the way from 0.5 hours up to 4. Okay, so here, probably start at 0, okay, and we're starting at 0 on both, so 0 to 50, 50 to 100, 100 to 150. Notice how it's consistent. I counted by 50s every time. I did every 5 squares was 50. So really, every 1 square vertically is me 10. So you can go 10, 20, 30, 40, 50. Now going across, I want to be able to include this 0.5. And I'm only going out to 4, and I'm covering this big distance. So I went every, what is this, 1, 2, 3, 4, 5, 6, 7 squares to get to 1. And really, you could go every 6 squares, so then your 0.5s are every 3. That might make it a little bit easier, and that's perfectly fine. We are going to try to fill the grid as much as possible, but you don't have to go overboard. Okay, so either one, if you did that, don't erase everything. But you don't want it too small. You definitely don't want to go by 1s and then only have 4 squares filled. You want to fill it up as much as possible. All right, don't forget to include your labels, time after eating, and glucose levels. So time is in hours, the glucose levels are in milliliters per liter of blood. Okay, so milliliters of glucose per liter of blood. All right. So again, you're answering the questions independent variable versus dependent variable. So you can think through the statement and try to read it in both ways. So we could say the length of time after eating depends on the glucose level. Well, that doesn't really make sense because the glucose level in your blood will fluctuate, and it's based on when you've eaten last and what you ate. And so the glucose level in your blood is really what depends on the time after you eat. So the independent variable is going to be time, where the dependent variable is going to be the glucose level. And so the independent variable being time is the independent variable because it passes no matter what, okay? And does not depend on the amount of glucose, where the level of glucose in your blood depends on how much time has passed. All right, so now that we have answered our questions, we've set up our scales, go ahead again with the different colors, plot in those values. Again, pause the video if you need a little bit more time. Okay, after you've paused it, or unpaused it, now you can take a look at the two graphs. And just like before, I'm going to connect my dots. That way I can really see what's happening. Where on this one, having my different colors, I can really see what's happening. But especially if you just used a pencil, you might not really be able to tell what's going on. So connecting these is going to help you out a little bit. And again, if you just use pencil, then also label these, so that way you can tell what's happening. Okay. So then we're going to interpret our graphs. So in question 10, it's saying, if the time period were extended to 6 hours, so we only have 4 here, if we went out to 6, what do you think is going to happen for person B? Okay, so what I did here is I just kind of gathered some data. I said, well, after 2 hours, person B was here. After 3 hours, they were here. After 4, they were here. So between 2 to 3 hours, we've decreased by 20. And then from 3 to 4, we decrease by 25. I'm just subtracting. 245 minus 225 is 20. 225 minus 200 is 25. So then chances are, as we increase our hours, we're going to decrease by either 20 or 25. 20 is a nice easy number to work with, so I just subtracted 20 each time. So then after 6 hours, it's pretty reasonable to say, yep, we're going to be at 160, just using kind of an average here. Okay, it's not an exact science. So if you subtract 25 every time and went down to maybe 150 here, that would be perfectly acceptable. So don't worry too much there. So I put anywhere between 150 to 160, but use your units, milliliters per liter. Okay, so now it's saying, well, what about person B at 3.5 hours? So let's take a look at our graph here. So here's 3.5 hours. We don't have a dot for either one. Remember, person B I graphed in red, so that's this one up here. So this is where, if you had connected your dots, it's going to be helpful. So I went from 3.5, and I just went up to wherever that line that I connected my dots with, wherever that is. Now I'm going to look across, and this is what, every square is 10, so it's somewhere between 210 and 220 milliliters per liter. Again, it's not exact. We're just using the graph to interpret. Okay, so either one, 210 or 220, but milliliters per liter, and you're using your graph for that. Okay. So, if you didn't get a chance to complete both graphs, you'll complete both of them as your homework. Otherwise, you're going to move on to the journey to the bus stop. That's the next page in your notes, but this time you're doing it on your own. Don't look at your neighbor. You can use your notes, of course, and so look back to yesterday's notes on distance time graphs to help you out. Okay, so again, you are completing the journey to the bus stop in your notes, as well as any of these graph examples if you hadn't gotten a chance to. So if you need to rewind the video, go back a little bit, go ahead and do so now.